Assalamu alaikum, brothers and sisters, welcome to the family of Quest. Have you ever wondered how we measure the health of vegetation across the globe? A question that may seem daunting at first, but with the power of technology and a clever technique called NDVI, or Normalized Difference Vegetation Index, it becomes a fascinating journey of discovery. NDVI plays a critical role in the realm of remote sensing, acting as our eyes in the sky, providing a unique perspective on the Earth's vegetation. It's a mathematical formula, but don't worry, it's not as intimidating as it sounds. It's essentially a measure calculated from the visible and near-infrared light reflected by vegetation. Healthy vegetation absorbs most of the visible light that hits it and reflects a large portion of the near-infrared light. Unhealthy or sparse vegetation reflects more visible light and less near-infrared light. Now, you might be wondering, why is this important? Well, understanding the health of vegetation is crucial in a myriad of applications. In agriculture, for instance, NDVI helps farmers identify unhealthy crops early on, allowing them to take corrective measures and improve yield. When it comes to climate change studies, NDVI offers valuable insights into how vegetation responds to changing environmental conditions, aiding in the prediction and mitigation of climate change impacts. In the field of forest management, the NDVI is a game changer. It allows us to monitor the health of forests, identify areas affected by disease or pests, and track the recovery of forests after wildfires or logging. The beauty of NDVI is that it's not a one-trick pony. It's a versatile tool that's applicable in various fields, from managing our food supply, combating climate change, to preserving our forests. It's a testament to how technology and scientific innovation can help us better understand and care for our planet. So you see, NDVI is an essential tool in understanding and managing our environment. A tool that, when wielded wisely, can help us ensure the vibrancy and sustainability of our world's vegetation for generations to come. Now you might ask, what exactly is NDVI and how does it work? Well, my friends, let's unravel this mystery together. NDVI, or Normalized Difference Vegetation Index, is a simple but powerful tool in remote sensing. It's like a secret agent that measures the health and vitality of vegetation. But how, you wonder? It's all about light, really. You see, plants are quite picky about the light they interact with. They strongly reflect near-infrared light, almost as if they're showing off to the satellites above. On the other hand, they absorb red light, using it as fuel for photosynthesis, their life-sustaining process. Now let's talk numbers. The NDVI formula is rather straightforward. It's the difference between near-infrared and red light, divided by their sum. This results in a value between -1 and +1. But why this range, you may ponder. It's because this range gives us a clear indication of the health of the vegetation. Higher values, closer to 1, suggest healthier vegetation. These plants are like the star athletes of the plant world, reflecting lots of near-infrared light and absorbing lots of red light for photosynthesis. Lower values, closer to 0 or even negative, indicate less healthy or sparse vegetation. These plants may be struggling, perhaps due to lack of water, disease, or other environmental stresses. But what about values around 0? These usually represent non-vegetated areas, like bodies of water, rocks, or bare soil. It's as if the NDVI is saying, nope, no plants to see here. So you see, the NDVI isn't just a number. It's a story, a tale of how vegetation interacts with light and its environment. It's a crucial tool for understanding our world from a bird's-eye view, helping us monitor everything from crop health to deforestation. With this understanding, we can now interpret NDVI values and what they mean for the vegetation in question. So, how do we make sense of these NDVI values? Well, the beauty of NDVI lies in its simplicity. The values it generates create a scale from -1 to +1. This range of values can be directly correlated to the state of vegetation in a given area. Let's start with values close to 1. These high values are indicative of dense, healthy vegetation. The reason behind this is the high level of chlorophyll in healthy plants, which absorbs visible light for photosynthesis and reflects near-infrared light. This reflection results in high NDVI values. So if you come across an NDVI value nearing 1, you can safely infer that the vegetation in that area is thriving. Now let's move towards the middle of the scale. NDVI values hovering around 0 represent areas with minimal or no vegetation. These could be areas of bare soil or rock where plant life is scarce. The absence of chlorophyll in these areas means there's no significant absorption of visible light or reflection of near-infrared light, resulting in NDVI values close to 0. But what about negative NDVI values? These are often associated with bodies of water. Water absorbs more visible and near-infrared light than it reflects, which results in negative NDVI values. Therefore, if you come across an NDVI value in the negatives, it's a good indicator that you're looking at a water body. Understanding and interpreting these NDVI values can be a game changer. It allows us to identify areas of concern or interest in a landscape. We can monitor the health of vegetation, track changes over time, and even identify patterns that may be indicative of larger environmental issues. The NDVI's ability to provide such valuable insights is a testament to its power as a remote sensing tool. Whether you're a researcher studying forest ecology, a farmer monitoring crop health, or a city planner mapping urban green spaces, interpreting NDVI values can give you a bird's-eye view of the health and status of vegetation in your area of interest. As we see, interpreting NDVI values gives us a clear picture of the health and status of vegetation. Now, how can we utilize NDVI in a practical sense, say using QGIS software? Well, let's start by understanding that the QGIS software is a powerful tool for spatial analysis, and the application of NDVI here is a perfect example of its capabilities. To apply NDVI in QGIS, we start by loading our satellite images into the software. QGIS is compatible with various image formats, so you can select the one that best suits your data. Once your images are loaded, we move on to the next step, the creation of the NDVI layer. Creating an NDVI layer involves a simple arithmetic operation. We subtract the red band from the near-infrared band, then divide the result by the sum of the two. This calculation is done pixel by pixel across the entire image, resulting in a new layer that represents the NDVI values. But what does this layer tell us? Well, it provides a visual representation of vegetation health across the landscape. The NDVI values are displayed in a range of colors, with each color corresponding to a different level of vegetation health. This allows us to easily identify areas of lush, healthy vegetation, as well as areas where vegetation might be struggling. Now, this information is not just pretty to look at, it's incredibly useful for a range of applications. Environmental scientists use it to monitor changes in vegetation over time, which can provide insights into the impacts of climate change, deforestation, and other environmental issues. But the power of NDVI and QGIS doesn't stop there. By incorporating other data sets, such as those related to climate or land use, we can perform more complex analyses. This allows us to make informed decisions about environmental management, conservation, agriculture, and more. So as you can see, applying NDVI and QGIS is not just a simple process, but a powerful tool for understanding our environment and making decisions that impact it. And that, my friends, is how we put NDVI to work in QGIS. All right, we've seen how NDVI is applied in QGIS. Now let's delve deeper into the NDVI formula and how it is executed in the QGIS software. The NDVI formula, as we know, is NIR red, NIR plus red. NIR stands for near-infrared light, which is the light reflected by vegetation. Red is the light absorbed by the vegetation. This formula helps us calculate the health and density of vegetation in a particular area. But how is this formula applied in QGIS software? Let's walk through the steps. First, we load our satellite image into the software. Next, we select the NIR and red bands from our image. Once we have these selected, we can apply the NDVI formula. Applying the NDVI formula in QGIS software is a simple process, but the results it produces are immensely valuable. The resultant NDVI layer is visualized as a color gradient, where green typically indicates healthy, dense vegetation, while red represents sparse or less healthy vegetation. The beauty of this formula and its application in QGIS is that it allows us to effectively monitor and assess the health and density of vegetation across vast areas. This is particularly useful in fields like agriculture, forestry, and environmental science, where understanding vegetation health is crucial. So armed with this formula and the power of QGIS software, we can make informed decisions, helping us better manage our environment and ensure the health of our planet's vegetation. And that, my friends, is the NDVI formula in action in QGIS. We've delved deep into the essence of NDVI, haven't we? Let's take a step back and revisit what we've learned. We embarked on an insightful journey into the intriguing world of the Normalized Difference Vegetation Index, or NDVI, as it's often referred to. We discovered that it is a straightforward yet effective gauge of plant health, computed by the difference between near-infrared and red light, bounced back by vegetation. Our journey then took us into the realm of decoding NDVI values. We understood the scale from -1 to +1 and its role in distinguishing between various forms of land cover, with higher values signifying more robust vegetation. Following that, we navigated through the application of this impactful tool in the QGIS software. We demonstrated the process of importing satellite imagery, calculating NDVI, and deciphering the resultant map, a pivotal skill in sectors like agriculture, forestry, and environmental science. We also took a deep dive into understanding the NDVI formula and its application in QGIS. Wrapping up, it's clear that with NDVI, we are better poised to monitor and manage our environment, making informed decisions that play to our advantage. Thanks for connecting to the family of Quest. To be part of this family, I request you to subscribe it and press the bell icon. Stay tuned.